Hello friends, this video on combustion and flame part 8 is brought to you by examfear.com. No more fear from exam. So now that we know about auto-ignition temperature and flash points, we see that there are certain combustible substances which can burn even more easily because their ignition temperature is very low. So such substances are called inflammable substances. They can catch fire very easily. Why? Because they have very low ignition temperature. So basically you can say that inflammable substances are those combustible substances which have very low ignition temperature. So in a way, all inflammable substances are combustible. But all combustible substances are not inflammable because there are many combustible substances which have relatively higher ignition temperature. So let us look at some examples of inflammable substances. So the first example is that of petrol. So if you look at petrol, it has an auto-ignition temperature. What is the auto-ignition temperature of petrol? It is 232 degrees Celsius. And the flash point of petrol is minus 65 degrees Celsius. So this is the auto-ignition temperature and this is the flash point. So if you see, auto-ignition is quite high. So that means petrol cannot catch fire on its own very easily because it has to be heated till to a temperature of at least 232 degrees Celsius. But if you look at the flash point, it is extremely low. So even at room temperature, it can very easily catch fire if there is a source of ignition. So petrol is an inflammable substance. Let us look at the next example of LPG. So in case of LPG, if you look at its auto-ignition temperature, so the auto-ignition temperature is in this range around 410 to 580 degrees. So this is the auto-ignition temperature. So it doesn't blast on its own suddenly. It has to be heated to this high temperature for that. But if you look at the flash point, again it is very low. It is minus 104 degrees Celsius. Just see, these are all in the negative range. So at room temperature, they are actually going to blast if there is a source of ignition. That is why you would have seen that it is always advised to check that your gas burner knobs are kept off when you are not using it, because if it is kept on, basically your LPG is going out of it. So your LPG is present in the atmosphere. So whenever it finds an ignition source, maybe through a matchstick or through a gas lighter or maybe through a bulb, so wherever it finds a little bit of heat or a little bit of source of ignition, it gets ignited and there will be a huge blast. You can take other examples also, for example, alcohol or diesel. So even they have very low values of flash points, somewhere around 16 degrees Celsius for alcohol. For diesel, it is around 52 degrees Celsius. So that means they are all examples of inflammable substances. So alcohol is also an inflammable substance. Diesel is also an example of inflammable substance. So such substances with extremely low ignition temperature so that they can catch fire very readily, they are called inflammable substances. So now that we have understood the concept of how objects catch fire, so let us try to understand in more detail how exactly a matchstick catches fire. Now we saw that friction plays a very important role in igniting a matchstick. Now before talking about the physical processes, let us talk about the constituent of the matchstick. What is present in the matchstick? So the most important role in ignition of a matchstick is played by phosphorus. So phosphorus plays the leading role. Now why is phosphorus an important constituent of matchstick? That's because of extremely reactive nature of phosphorus. So if you remember when we were discussing the lesson on metals and non-metals, I told you that phosphorus is an extremely reactive metal. So if it is left open, exposed to air, it catches fire. So it readily reacts with oxygen to catch fire. So that is why how do we store phosphorus? It is generally stored inside water because phosphorus doesn't react with water. So this phosphorus is an important constituent of the head of the matchstick. So here you have phosphorus. So now there are two types of phosphorus which exist. One is white phosphorus and the other one is red phosphorus. Now white phosphorus ignite even more spontaneously in air, and it is also unstable and very much volatile and sensitive. So that is why instead of using white phosphorus directly, these days red phosphorus is used in the head of the matchstick. So this is red phosphorus, and white phosphorus is extremely harmful also. So considering all these advantages and disadvantages, red phosphorus is used as a constituent of the head of matchsticks. So it is not only phosphorus which is present in the matchstick. Along with red phosphorus, we also have small amount of potassium chlorate and sulfur. So potassium chlorate is KClO3. This is also present, and sulfur is also present in small amounts. Now, why do we have all of these together? That's because the purpose of phosphorus is to initiate the ignition, because phosphorus is extremely reactive. So it can cause the ignition. But now that ignition happens, but then it will stop immediately. So in order to have the ignition for a longer duration, that is why we have potassium chlorate and sulfur. So we will see that potassium chlorate helps in releasing little more of oxygen, and that oxygen will combine with this sulfur to again cause ignition, because sulfur is also very reactive. So when it gets some extra oxygen from potassium chlorate, so it reacts with that oxygen and again it helps to retain the ignition. So that's how the your matchstick remains ignited for a longer time. So that's how the entire process happens. So these are the constituents of your matchstick. So now we will look at the entire process in more detail, step by step. So this is a recap of the entire process. So as I said, phosphorus plays the most important role. Which type of phosphorus do we use? We use red phosphorus, as you can see here. Now the head of the matchstick looks little more red, so that is also because of the artificial color which is being put there. But otherwise red phosphorus is present here. Now what is the first thing that we do if we want to ignite a matchstick? We strike it. When we strike it, what happens? There is friction, and friction produces heat. So heat is produced. Now once this heat is produced, what happens? The red phosphorus gets heated up. So when it gets heated up, it gets converted into white phosphorus. So some red phosphorus will get converted into white phosphorus, and white phosphorus, as I said, is extremely reactive. It is extremely volatile. So this white phosphorus will immediately react with the oxygen which is present in the surroundings, and a lot of heat will be generated, and we will see the ignition. So we could see the flame in the matchstick. So now the huge amount of heat that gets generated, so this heat is sufficient to break down potassium chlorate. Now as I said, potassium chlorate is also present along with red phosphorus. So what happens? This potassium chlorate, that is KClO3. Potassium chlorate, it acts as an oxidizing agent and it releases oxygen. So due to this heat which is generated due to the reaction of phosphorus with oxygen, so the heat will break down potassium chlorate to release oxygen. So as a result, oxygen will be released. Now when this extra oxygen gets released, the sulfur, the small amount of sulfur which is present there, that quickly reacts with this oxygen to form sulfur dioxide, and during this process again a flame is produced. So that's how the flame which was initiated by this phosphorus, because here also the phosphorus basically reacted with oxygen to form phosphorus pentoxide, and during this process the fire was initiated or the flame was formed. So that flame was retained for a longer time due to the reaction of sulfur with oxygen. So from where did the sulfur get the oxygen? From potassium chlorate. So that is why we have potassium chlorate and sulfur in addition to phosphorus. So this is how exactly matchstick is ignited. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.